Morning. It's Thursday, August 29th, and welcome again to Social 3311 Social Statistics Online. This morning I'd like to take a few minutes and walk you through Chapter 1 of Healey. It's the introduction chapter. It's basically a chapter of sort of a glossary of terms of consequence to us as we proceed through the semester. You'll see these terms many times over the course of the next several weeks. Many of them will become part or are part of the conceptual way of understanding how statistics work. Remember I spoke about this before, that as much as anything, perhaps more than anything, you're gaining a conceptual understanding of the value of statistics and why statistics are done. Sort of a critical thinking of statistics is at least as important, perhaps more important, than the actual calculations that we'll do this semester. So do pay some close attention to the bolded terms, and I'll walk you through the essential ones this morning. I'm looking at the learning objectives on, I'm not sure what page it is. It must be, well, why not? Page 1. In this chapter he talks about describing the limited but crucial role of statistics in social research. I'm not inclined to think of it as a limited role. It doesn't do everything in social research, but maybe what Healey is talking about here is a crucial role. It is of significant value, as you will see. Now, there's qualitative research and there's quantitative research. And qualitative research is more about the human meaning of social phenomena, and it has very little to do with quantifying that phenomenon. So statistics clearly didn't have much of a role there. But on the quantitative side, things that are the product of surveys and counts and data, which they describe here as numerical information. Anything that's got numerical information, statistics is absolutely essential. So we'll say limited but crucial, but we'll qualify as limited and say in some circumstances it's absolutely vital. Okay. The other learning objectives for this chapter are univariate, descriptive, bivariate, descriptive, and inferential. And we spoke a little bit about this in the introductory video. Descriptive is things like means and averages and rates and ratios. A lot of the second chapter of the text is descriptive statistics, and in fact chapters 2, 3, and 4 are descriptive statistics, and we'll talk about those in the near future. He refers to univariate, which is a descriptive of a single variable. Say income, it varies. Some have more income than others, some have lower income than others, somewhere in between. What's the average income? That variable would be a univariate. And he talks about bivariate descriptive. Now, I don't usually think of it as a bivariate descriptive. When we get into bivariate relationships between two variables, I think of more of it in terms of explanatory, but we'll make those distinctions as we go through the semester, and I'll speak to them again here in a minute. But when we're looking at two variables, we're looking at how they associate with one another. Like we'll take education, for example. As we describe education going up and down, we're also describing income going up and down because it moves in response, shall we say, to education. So in a sense, there's a descriptive way of looking at that relationship. So we'll want to keep that in mind. Healey's correct. But we'll take it another level and say what we're doing when we talk about education going up and down, we're actually looking at that as a way of explaining why income goes up and down. So what he calls descriptive, yes, it is descriptive about the relationship between those two variables, but it is also an explanatory statistic, which we'll talk about later in the semester, how education explains the variation and why, not that they just co-vary in a descriptive way. And inferential statistics is a lot of what statistics is all about, the reasons why it was founded in the first place, I guess you'd say founded, in the 19th century. But it's really about samples, drawing down samples from a large population or a population, that if we wanted to know something about the average income of a population, it would take too much time and effort and expense, too expensive to talk to all million people in the city, and then add up all their income and divide by 1,000,000 to get the average, which we'll talk about in Chapter 2, how to get averages and means if you don't already know those things. But that would be a lot of work. So what we do is we draw down a representative sample of 1,000, let's say, and ask the questions of 1,000. Much easier to do, less expensive, and something we can do in a reasonable amount of time. Get the average of that income and then make the inference that had we asked the population, that is the value we got from that sample would have been the same. Now, or similar. Now, it's contingent on a number of things, that the sample is random, and we'll talk about this later, and that the sample is large enough to be a value, numerical value, to make that inference. But that's basically what inferential statistics is about. It's about asking questions of a sample that we'd really like to ask of a population, but we haven't time and money to do it. We're going to distinguish between discrete and continuous variables. Continuous variables are those variables that are that have a zero, and you can put fractions in them and all of that sort of thing, like $18.73 or something like that, 142 pounds and 8 ounces, whatever, that you can get fractions in them. Discrete variables are different. They're things like how many children does a family have? It has 3 children or 2 children or 4 children. There's no average there. You don't have an average. Although you can calculate averages on the overall population, but an individual family wouldn't have an average necessarily. It'd be hard to do, hard to think about that even. So discrete is something like I have 1 child, I have 2 child, I have 3 child. We'll see in a little while in the video that's also an interval variable, because if you have no children, then you have 1 child that goes up by 1, then you have another child that goes up by 1 again to 2, you have another child that goes up by 1, and that's 3. The interval is constant. So these discrete variables are often also termed interval variables. And then we're going to spend some time looking at 3 levels of measurement. These have to do with variables and types, how they're specified. Gender, for example, is male and female. There's no numerical value between them. It's just simply a category, a container of people who are female and people who are male. That's a categorical variable. It's a nominal variable because the difference is in name only, female and male, like African American and non-Hispanic white, or Hispanic white. No numerical value, no scale between them, simply they're in a container of names. This person is in the African American container, this one is in. These are categorical variables. Again, we're distinguished by categories of race and ethnicity. Ordinal variables we'll talk about here in a little while. Ordinal generally have to do with attitudes. Very happy, happy, not so happy. Each of those is kind of a category of happiness, and they're not as clear to distinguish as would be, say, male and female. It takes some discussion to see exactly how do we want to define very happy as opposed to happy. My very happy, maybe you're happy because you're an extraordinarily happy person. So well, it takes some consensus on the part of the researchers and practitioners to come up with the terms, or how to define very happy, happy, and unhappy. But that's generally the characteristic of any variable that's attitudinal. The third level of measurement, which does, and ordinal does have a scale if you think about it. It's not numerical in that sense, but a scale in the sense of not happy to very happy. The scale is implied. Ordinal, there's an order to them, like a nominal, there's a nombre, name to it. Ordinal has an ordinal order to it, and then interval continual. Right here in a minute. Interval ratio variables are the interval where 1 child plus 1 is 2 child plus 1 is 3, and then a ratio of those that you can have none or you can have a lot, like income. You may not have any money, or you may have a gajillion, and the rest of it has something somewhere in between, and you can make fractions out of it. That's continuous. Okay, so we'll kind of go through those things for a little while this morning. On the first page, talk about data being numerical information. Just get your mind around that. You'll see how that works. We'll talk a lot about data as it goes by, to distinguish the things that we would say in qualitative are not really characteristics of numerical data. And then statistics, as they define it here, are mathematical techniques to organize and manipulate data, numerical information, for the purposes of answering questions and testing theories, and we'll talk about that here now. A theory is a set of statements that purport to explain something. Conflict theory is often used as a way to characterize how people, shall we say, get along or don't get along. There's conflicts between gender, conflict between races, conflict between classes, conflict between nations. It's a very decidedly negative point of view, but it is a theory that says that until people become more familiar with one another, they're likely to be in some kind of, I'm not so sure about you, or wanting to be protective of their own interests until they get a chance to know the other person. And you might expect over the eons that's the way we were. We were living in our villages and doing whatever, and then some stranger comes. We say, well, I don't know who you are. We want to come out and meet with you out there before you come in to us. Maybe it's just a natural consequence of our own caution in the world. Maybe it gets in the way sometimes in terms of interpersonal relationships. Maybe that's where it comes from. In terms of conflict theory, we got off on that one, didn't we? An explanation of the relationships between phenomena is the term that they use here. Now they've got a research wheel of science that I put up here on the board, and I hope you can see it. Theory is up here at the top, and if we have a theory, then we have a hypothesis. This is looking for my, oh, here it is, my Mark-a-lot. We have a y equals x, and we might even put a WH up here for why, just to be fun, right? So we might say one of the illustrations, or the illustrations they use here in the text on page 3, is prejudice and contact. And just like what we were saying a moment ago, in conflict theory, we might imagine that racial groups will have some degree of conflict or caution in relation to one another at the outset. Because we seem to be different, because we kind of look different. But once we become more familiar with one another, we realize, well, you're just like I am, or I'm just like you are, and there's all the reason in the world for us to get along. That's the way it's supposed to work, right? And so we might have that theory here, and conflict, and let's say that here we put prejudice, which is the way they talk about it, equals contact. So our question here is, why is there prejudice in this world? Why are some more prejudiced and some less prejudiced and some in between, perhaps some none? So that's the question, the research question, the why. In the textbook, this is the dependent variable. When we're talking about a couple of variables that are going to be crucial to us, the why, the dependent variable, is the question, is what we're wanting to answer. What does this dependent variable equals an independent variable? Hope you can see this on the screen. What does this variation here depend on? Well, we're saying in this illustration of Healey, it depends on the degree of contact. We're saying that as contact goes up, prejudice goes down. If we think of this as a numerical data, where we have percentages and proportions of people who are prejudiced and percentages and proportions of people who have greater degrees of contact with one another, we can establish statistically that as contact goes up, frequency of contact, the frequency of prejudice goes down. And so our theory, conflict theory, is that things are conflictual. Is that the right word? And so our hypothesis is that y equals x. If we want to demonstrate our hypothesis that the more contact there is, the lower the prejudice is. And so then we go around and we have observations. Perhaps we do a survey and we ask questions of one another about racial relationships and frequency of contact with others. So in that survey, we might discover, indeed, that those who say they see fewer racial groups other than their own tend to carry some degree of prejudice or discrimination. And we can find that out, say, through a survey. So those are our observations. We're using a survey as the observation. And then we come over here to our empirical findings and we say, well, yes, what we discovered in our survey is, in fact, those with low contact have higher levels of prejudice. And so our empirical findings, which are the product of our observations and survey, support a hypothesis and to some extent support the theory of conflict, which in this case would say the less contact, the more prejudice. What we're finding here that that's so, but we're also finding in the inverse, the more contact, the less prejudice. So that's how that business of theory and hypothesis and all would work in that research, how they call it, wheel of science. And here in the dependent variable. So this would be, again, using your illustration on page 3 or 4, the dependent variable is prejudice. What does that range of prejudice depend on? It depends on an independent variable, which we're hypothesizing is contact. So as contact goes up, prejudice goes down, and we try and demonstrate that with observation, reveal that with observations and demonstrate that this hypothesis is so. Now we call these independent variables because we might have situations where y equals x1 plus x2 plus, let's just call it xk, standing for a number of x's. So when we say independent variables, and you'll see this later in the semester, this may be something that we're interested in, x1's relationship to y, independently of this. This may be contact, and this may be education, and maybe this is gender. So here in this equation, we're looking at prejudice in relation to contact. But also, we could look at independently of the relationship of prejudice to education, independently of the relationship between prejudice and gender. So that's why we use this word independent. Not always clear when you put independent out there. Independent of what? And independent is one of those words you'll see come up frequently during, not frequently, but often during statistics, and it always means something a little bit different, so it's kind of a freaky thing, but we'll work our way around it. But this is basically what the first couple of pages, 3 or 4 pages of that chapter are about, and you'll see that on page 3. And again, variable is important as a term because prejudice varies. It varies from one individual to another. So that means that prejudice is a variable. And when we get to descriptive statistics in chapter 2, 3, and 4, we'll look at how to describe the internal variation of a particular variable. Get its means, its averages, and all that sort of thing. Okay, we can hypothesis on page 4. On page bottom of page 6 and 7, they talk about descriptive and inferential statistics. I think we've talked about that already, pretty much. I think you can get that. Measures of association. Measure is another way of thinking about relationships between two variables. You'll see in social sciences, and if you take courses in biology and physical sciences, you'll see that things are less causal than we ever imagined they might be. I've done this before. I don't know if I can do it holding the book in my hand, but if I took my keys, let's say, and I threw them up, we've got the law of gravity, so they come back, right? But there'll be one time, if we stood here long enough, when they would not come back. Even in the physical sciences, there are probabilities. We've learned that over the 20th century. And so here, we don't talk about X causing Y, contact causing this. We know people who have a lot of contact with people of a different race, and they still are prejudicial. So here, what we're talking about is measures of association. These are highly associated in the sense that as this goes up, contact goes up, prejudice goes down. But not in every case. These are average movements. On average, as this goes up, on average, this goes down. This doesn't speak to individuals, it speaks to averages of groups and populations. So measures of association, this is not X causes Y, it's just these two variables are highly associated. And we'll talk about directions of association and that sort of thing later in the semester. Okay. On page 8 and 9, it talks about inferential statistics on 8. The point there is that whenever somebody says how would you quickly define inferential statistics? You say because it's based on a sample. We can't find out what we want from a population, so we pull down a representative sample and ask the sample. So a key way of thinking about the difference between inferential statistics and other kinds of statistics. All right, on page 9, they talk about discrete and continuous variables. We spoke about that. 1 car, 2 car, 3 car, 4 car, or some things that can be broken down into a value or variable that can be broken down into fractions, like so many pounds and ounces and so many dollars and cents and things like that. All right, so the next thing that we want to look at, and I'm going to do a little erasing here, is level of measurement. Pardon my back while I erase. I have to hold on to the whiteboard to keep it from falling off the tripod or whatever this thing is that it's sitting on. All right. Level of measurement. We'll just call it loam. Let that be a mantra in the evenings at midnight when you're sitting in the lotus position before you go to sleep. Loam. I'm sort of joking, but I'm sort of not joking. Not that you have to do meditation and sitting in a lotus position to get through this class, but you do want to keep this well in mind, because level of measurement is going to be a critical determinant of which statistical procedure you use as we move through the semester. If some procedures are for categorical variables and some for continuous variables, and you don't want to put a procedure on a categorical that belongs to continuous because you're going to get the wrong answer. Simple as that. So level of measurement is important to get your mind around and in and through and all of that. So if it does take a meditation moment in the lotus position at midnight to get loam, then do so. All right, level of measurement. There are 3 kinds here. I'm going to write them down. Nominal, ordinal, we just spoke of them a minute ago, and interval ratio. Pardon my back. All right. These are the 3 ways of levels of measurement. Here, there is no measurement, basically. Measurement is 0. This would be, let's say, gender, where we have male and female. This is these 2 here are categorical, and this one here is continuous. That'll work. That's an arrow. So gender is categorical. There's no numerical difference, in a sense, no value, measurable value between male and female in a numerical sense. There are a lot of values for males and a lot of values for females indeed. But I mean in a numerical sense, let's say. Or race and ethnicity, or Protestant and Catholic. Those are categorical variables or categories of individuals. Protestants and Catholics, males and females. And they're distinguished by nombre, name only. Ordinal, this implies a scale. This has no scale. There's a scale implied when we say order, ordinal. And these are often attitude variables, like happiness, the easy one to illustrate. Very happy, happy, not so happy. And we can see the order of it because we say when we're very happy, we are like high. And when we're not so happy, we're down. We're blue, we're down. So it's not so happy, happy, and very happy. There's an order. There's a sense in us that there's an order to these attitudinal variables. Even though we can't quantify it, we have a sense in the background, there's an order implied. And then interval ratio. Again, interval might be something 1 child plus 1 is 2 child plus 1 is 3 child plus 1 is 4 child. And then ratio is a variable where you have 0 or a gajillion, like dollars, and things like that. So, and these are called continuous variables, the interval ratio and the ratio. This could be money, could be weight, could be any number of things that you can get fractions of. That's one way to think about it. This one has a constant interval as you move from one to the other. This one can be broken down into zeros and fractions and that sort of thing. So that's the level of measurement. Pay close attention to it. Get your mind into it, around it. And if it requires a meditation moment at midnight, do so. Loam is what you'd want to say, I suspect. I think they do some very good work here in the last 3 or 4 pages of this chapter describing what levels of measurement are with illustrations. So let's let go of the chapter. I want to say before I close that homework 1 is now posted. Take a look at homework 1. It's assigned today and due on the 10th of September. Here you'll see that there are several problems from the back of the chapter of chapter 1, and that will be the case. Most often there will be even problems because those answers are not in the back of the book. But anyway, you'll see that most of these in this chapter, because it's a glossary chapter, conceptual. So go through that and write these things in your own words. I put it in italics. Do not copy Healey's phrasing. Take Healey's phrasing, think it through, and then write it out in your own words. Now, problem 1.2 on page 17, I refer you to this article. It is Whistle While You Work, the Effect of Household Task Performance on Women's and Men's Well-Being. Now, what I'd like for you to do with this, well, you'll see what you're supposed to do in that problem. It'll ask you to do certain things. But what is the research question? Well, I erased it, didn't I? What is the research question for this paper? What are the authors of this paper trying to answer? And then, how are they answering it? What is their hypothesis? So think about that. Read the paper and think about what is the research question and how are the authors attempting to answer this. Also, you'll be asked to kind of take a look at the statistics, get a sense, is there a lot of statistics in this? Some statistics, a little bit of statistics. Get a reading, if you will, and a sense of how much statistics is used to answer that question. So I think you'll like this paper. It's got an interesting subject anyway that has to do with gender and in the household. So I think you'll find it kind of an interesting take on that phenomenon. And then we'll look at this again at the end of the semester, and where you might struggle some over the next week or so to figure this rascal out. And at the end of the semester, I think you'll find reading this paper, rereading it. Oh yes, I see this now. Oh yeah, I understand this. So anyway, I think that's it for today. Tomorrow, or rather next week at some point, I'm not sure about Tuesday, Monday being a holiday and how all that will work. I might not get a video posted on Tuesday, but I will for sure post a video no later than the end of the day on Thursday of next week. So, again, welcome to Soci 3311, and it's Thursday and there's a weekend coming up. Y'all be safe out there, and take care.